So this is the National 4, National 5 chemistry lesson on Unit 3, Chemistry and Society, and this is a continuation of our set of lessons on fertilizers. And today we're going to look at one of the steps involved in the production of fertilizers and a process called the Haber process. So the aim of today's lesson is to understand the process by which ammonia is produced. Our success criteria is to state how ammonia is produced, to understand the test for ammonia, and to understand what catalyst is used in the Haber process. Also to describe the best conditions for the production of ammonia. So fertilizers are a big business, and there are two main processes used to start off the production of most fertilizers. The first one of those is the production of ammonia, Nh3, in a process we call the Haber process. Now, firstly, we'll get into the properties of ammonia. Ammonia has the chemical formula Nh3. It is a colourless gas, but it has a distinctive sharp smell. Apparently, it smells like cat pee. I don't have a cat, so I don't know. Also, we know that the shape of Nh3 from work we did in Unit 1, that it is trigonal pyramidal in shape. Now, the Haber process is the process by which ammonia is made. So ammonia is made from nitrogen gas, which we find in the air, and it is combined with hydrogen, which is produced in the petrochemical industry. And the petrochemical industry is the oil industry, essentially. Now, nitrogen and hydrogen combine together to give us ammonia. And the equation for that, balanced equation, we need 1 nitrogen, remember nitrogen is a diatomic molecule, plus 3 hydrogens, those are diatomic molecules as well, to give us 2 molecules of ammonia. So N2 plus 3H2 gives us 2 NH3. Now, the Haber process between nitrogen and hydrogen requires an iron catalyst, and you're expected to remember that the Haber process uses an iron catalyst, and that this process is reversible. So normally you're used to seeing an arrow that just points one direction for a chemical reaction, but the Haber process actually is reversible, and the ammonia is capable of turning back into nitrogen and hydrogen. And so it's important that conditions are chosen for this reaction that favour it going towards the ammonia and stop it from going back towards the starting materials. So as I said, the formation of ammonia is a reversible reaction, and this means that not all of the nitrogen and hydrogen are converted into ammonia when you try the reaction. Now, the Haber process, the conditions for doing the Haber process. If you try the Haber process at low temperatures, you're actually able to make a high amount of ammonia, but we know that low temperatures means low reaction rate, and so this large amount of ammonia is produced very slowly. At high temperatures, you create a small amount of ammonia, but you're able to produce it quicker. And so if we want to get the best rate of conversion into ammonia, it involves a very careful choice of reaction conditions. The best conditions are 300 to 500 degrees centigrade. That's not considered either low or high for industry. 300 to 500 degrees is a medium temperature. And so what that means is that you're able to still do the reaction quite quickly, but also produce a decent yield of the final product. So you get it fast and you get a decent yield. The pressure of 150 to 300 atmospheres, that's a high pressure. 150 to 300 atmospheres, that is high pressure, and that also helps to make more of the ammonia and stops the production going backwards to make the nitrogen and hydrogen. So we have 300 to 500 degrees temperature, 150 to 300 atmospheres of pressure, and we use the iron catalyst. Now the catalyst is needed to make the reaction go as quickly as possible by lowering the activation energy. So the Haber process looks like this, and there's two key points that you need to remember from this. So I'll talk through the process. Starting at the left-hand side, you have nitrogen, which is taken from the air, and hydrogen, which is taken from the petrochemical industry. Those get combined together in a compressor. What a compressor does is basically it pushes them together and increases the pressure to that 150 to 300 atmospheres of pressure. The reaction is heated in the compressor as well and is moved into a catalyst chamber. So that's where the iron is found, and the compressed gases are passed over the iron, and as they pass over the iron, they will convert into ammonia mostly, but we'll still have some unreacted nitrogen and hydrogen. Now, ammonia, if you cool it down enough, it will condense, and so it will turn into a liquid, whereas the nitrogen and hydrogen will not turn into liquids. So the condenser allows the ammonia to be separated from any unreacted nitrogen and hydrogen, and what's really important is that any nitrogen and hydrogen that are left unreacted at the end get recycled back into the catalyst chamber. So the two most important things to remember are, one, the catalyst chamber. That's where the reaction is happening, and the catalyst is iron. The second important thing is to know that the reactants get recycled from the condenser back into the catalyst chamber. It's a very common question to have to draw an arrow showing how this process prevents loss of material, or how the processes help to save money, and that is by recycling your reactants back in. So you need to know that that happens. So you are expected to know the test for ammonia gas, and you're also expected to know the test for carbon dioxide, hydrogen, and oxygen. But we're going to focus on the test for ammonia gas because that's the most important one for this lesson. Now, the test for ammonia gas is actually a test for ammonium compounds. Now, what you do is, if you have a fertilizer that's made of ammonium, you can add a base to it, something like soda lime, so something that would give an alkali solution to it. You will, there will be a reaction happening. You may see bubbling, but often you don't. But you will probably start to smell the ammonia gas be produced. And if you want to confirm that that smell is ammonia, you put some damp pH paper over the neck of the tube and you look to see if it changes colour. If it changes blue, then you have produced ammonia gas. So the properties of ammonia, some of these we went over at the start, but ammonia is very, very, very highly soluble. So it dissolves very, very easily in water, and it produces an alkaline solution. It actually reacts with water to produce something called ammonium hydroxide. And ammonia gas will turn moist or wet or damp pH paper blue. That is the test, that second point. Ammonia gas turns moist pH paper blue. It needs to be wet, otherwise the gas won't do anything. And it will turn it blue because it's making it an alkali. So next what we have is how to use ammonia. And ammonia, in regards to making fertilizers, ammonia is not, can be used directly to make some fertilizers if you want a fertilizer to contain ammonium ions, but ammonia is also importantly used to make nitric acid, which has the formula HNO3. Now, the process by which ammonia makes nitric acid is called the Ostwald process, and we'll explore that in more detail in a future lesson. So, going over our success criteria for today, you should be able to state how ammonia is processed or produced. The name of that is the Haber process. You should know the test for ammonia. Ammonia gas will turn damp pH paper blue. And you should know the catalyst used for making ammonia. That catalyst is iron. And the best conditions for the production of ammonia are 300 to 500 degrees centigrade and 150 to 300 atmospheres of pressure. And of course, you have to say that you use an iron catalyst. So now we have a few questions related to ammonia and the Haber process. So firstly, identify the metal which is used as the catalyst in the Haber process. That is D, iron. Next question, so this is a flow diagram and you have to draw an arrow to show how the process can be made more economical. Now, more economical means less waste. So you're looking for a way of saving money or looking at a way of recycling products or unreacted material. And on this, you've got your nitrogen and hydrogen gas, which is going into the catalyst. You produce a mixture, it goes into a separator, and that separator gives you ammonia, but it also produces some unreacted gases. What you have to do is show that those unreacted gases, which are nitrogen and hydrogen, can be put back into the catalyst to try and make more ammonia. It's always that arrow in this type of question. So we've now got an experiment to prepare small quantities of ammonia in the lab. What colour would the pH paper turn, damp pH paper turn, after this mixture of ammonium and a base or alkali are heated? Well, that's the test for ammonia, so the colour is blue. And finally, let's see if you can remember it again, which metal is used as the catalyst in the industrial manufacture of ammonia? And of course, again, the answer is iron. So that has been ammonia and the Haber process. And next time we will see more about fertilizers.